Science often takes its time to guide us into slumber. Tonight, let's slow down and step back into one of the most captivating chapters of our planet's story, a time long before humans, long before cities, long before our species walked the Earth. This was the Jurassic period. You've probably heard the word countless times, usually tied to towering dinosaurs, razor-sharp teeth, and the thunder of colossal footsteps. But reality is far more intricate, far stranger, and far richer than the blockbuster images pop culture often shows us. And together, we'll move gently into that world, not rushing, not forcing, just letting the story unfold naturally, like landscapes passing outside a train window. Before we dive fully, pause for a moment and consider your own surroundings. What time is it where you are? Is it late, with dim lights and a cooler air, your body ready to settle into rest? Or is it earlier, a brief pause carved out amidst a busy day? Are you lying in bed, perched on a couch, or somewhere else entirely, headphones on, letting this narrative carry you away? Wherever you are, this is the perfect time. You've made space for this moment, and that alone is enough to join this journey. If you enjoy this kind of unhurried exploration, learning without pressure or rush, without the sharp edges science sometimes carries, consider tapping the like button or subscribing. It helps this quiet corner of curiosity reach others seeking a gentle landing at the end of a long day, keeping the path open for anyone who wants to explore the world while relaxing their thoughts. Now, let's ease into the Jurassic. This period, stretching roughly from 201 million to 145 million years ago, was no mere backdrop for giant reptiles. Consider the span of time it dwarfs all of human history, where civilizations rise and fall, technologies emerge and vanish, entire cultures leave their mark and fade. Compared to that, human existence is a flicker. Yet, despite such vast stretches, the Earth would not have felt entirely alien. The sun rose and set, the moon tugged at the tides, clouds formed, rain fell, rivers carved valleys, and forests rose. Much would feel familiar, even as differences stood out. The Jurassic was the middle act of the Mesozoic era, the so-called age of dinosaurs. But it wasn't only about dinosaurs. Plants were evolving and spreading, oceans teemed with unfamiliar life, continents were slowly drifting apart, volcanoes shaped mountains, and storms swept across wide-open coasts. The planet itself was restless, and life adapted, changed, and grew in response. Imagine entering that world. The first sensation would be warmth. Earth was a greenhouse planet, even the poles temperate. The air humid and heavy, forests of conifers, cycads, and ferns dominated the landscape. Towering trees with needle-like canopies, clusters of cycads, and ferns carpeting the ground created lush, unfamiliar greens. Grasses didn't exist yet. Movement in this world revealed life. Branches shifting as creatures brushed past, tails swinging, necks arching to reach leaves. Dinosaurs roamed, some massive, some small and nimble, but they shared space with insects, early mammals, and primitive birds. Oceans rippled with marine reptiles like plesiosaurs and ichthyosaurs. Life wasn't a parade for an audience. It was ecosystems at work, predators and prey, plants and pollinators, cycles of growth and decay. Every creature, no matter its size, was part of a vast network. They lived life without knowing they would become fossils, studied by distant descendants. Their lives were ordinary yet extraordinary in their interconnection. A reminder that survival shapes all life, everywhere. The land itself was changing. Pangaea, the supercontinent, was breaking apart, forming new seas and coastlines, shaping habitats and migration paths. Imagine continents slowly drifting, oceans widening, shorelines stretching, volcanoes rumbled, rivers carved valleys, mountains rose. To creatures in the forest, these weren't geological events, they were new rivers to navigate, cliffs to avoid, forests to explore. Yet these gradual shifts laid the foundation for the Earth we know today. The climate was different too. Continental interiors experienced extremes. Deserts and forests coexisted, while poles supported vegetation instead of ice. Forests stretched almost everywhere, supported by higher atmospheric carbon dioxide that trapped heat, creating a greenhouse world. Seasons existed but were milder. Rainfall was abundant near coasts, while interiors saw drier conditions. Air was humid, warm, rich with plant life, carrying the sounds of insects, amphibians, dinosaurs, and flying reptiles. Nights revealed bright stars, a larger moon, and stronger tides. The Jurassic was alive in ways more profound than a simple image of dinosaurs stomping across a stage. Rivers ran, storms rolled, animals hunted, mated, and rested all within a climate that nurtured their existence. Sauropods and stegosaurs fed on dense vegetation. Predators thrived on herbivores, insects buzzed, birds fed, and the ecosystem remained interconnected. The greenhouse conditions allowed life to flourish, supporting growth, reproduction, and evolution across species and environments. Everything the climate, vegetation, oceans, air shaped life. While life shaped its environment, it was a world in constant motion, ever adapting, and profoundly alive. Though it existed millions of years ago, the principles of life, rhythms of day and night, cycles of survival remain recognizable. The Jurassic Earth was not frozen in time. It was dynamic, teeming, and breathtaking. The Jurassic atmosphere was never stagnant. It evolved slowly over millions of years. Volcanic pulses raised carbon dioxide, occasionally followed by periods of slight decline. Temperatures fluctuated in response, but remained far warmer than today, creating a greenhouse world that supported life on an extraordinary scale. This climate wasn't just scenery, it powered the age. It allowed plants to cover continents in green, herbivores to grow enormous on endless food, predators to roam vast territories, and oceans to teem with coral reefs, fish, and marine reptiles. It influenced migration, behavior, and evolution itself. Around 200 million years ago, Earth looked very different. Today's continents, Africa, South America, North America, were once connected in a supercontinent called Pangaea. By the early Jurassic, Pangaea was slowly fragmenting. This was no dramatic split. Deep within Earth, mantle convection created cracks that widened into rifts, filled with molten rock, and eventually cooled into new crust. These rifts marked the birth of oceans such as the early Atlantic. At first, they were simple valleys, sometimes flooded by water, sometimes filled with lava. Over millions of years, these slow movements shaped the coastlines we recognize today. The breakup of Pangaea reshaped climate and ecosystems. Inland deserts gave way to forests as new coastlines, and seaways moderated rainfall. Isolation of landmasses drove evolution, allowing distinct species to emerge in different regions. Volcanic activity fueled this transformation, releasing gases, enriching soils, and creating new habitats, while rift valleys preserved fossil evidence of early Jurassic life and formations. Like the Newark Supergroup. As the supercontinent split, two major landmasses formed: Laurasia in the north and Gondwana in the south, separated by the Tethys Ocean. The Tethys, warm, shallow, and nutrient-rich, hosted coral reefs, fish, ammonites, and marine reptiles like ichthyosaurs and plesiosaurs. Its currents redistributed heat and nutrients, sustaining a vibrant marine food web. The formation of new seas altered rainfall, reshaped coastlines, and created diverse habitats for both terrestrial and marine life. Shallow seas allowed sunlight to fuel photosynthesis, forming the base for vast food chains, while storms and hurricanes redistributed nutrients and sculpted landscapes. Ocean chemistry supported shell-building organisms, ensuring reefs thrived, and ammonites became abundant, forming crucial links in marine ecosystems. On land, the first thing one would notice in the Jurassic was the plants. Towering trees, sprawling ferns, and dense cycads structured the landscape. Grasses were absent. Instead, the ground was carpeted with ferns, forming waist-high to chest-high prairies. Cycads, palm-like plants with stiff leaves, and conifers, the giants of the forest, dominated. Conifers could reach over 100 feet, shaping ecosystems with their shade. Fallen needles and seeds, horsetails thrived in wetlands, growing up to 30 feet, stabilizing soils and providing cover. These plants shaped the environment, providing food, shelter, and the oxygen that sustained giant herbivores and active predators alike. Fires, lightning, and volcanic activity created cycles of destruction and regrowth, with ferns often leading the recovery. Ferns were foundational, covering open plains and understories alike. Their spores spread widely, enabling rapid colonization. They supported large herbivores, offered cover to small animals, and maintained ecosystem balance. Forest understories formed labyrinths where early mammals and reptiles navigated for survival. Fossil evidence shows ferns were abundant, dense, and pivotal in nutrient cycling and soil stability, acting as pioneers after disturbances. Meanwhile, the seas teemed with life. Ichthyosaurs, dolphin-like reptiles, reached lengths over 15 meters, hunting fish, squid, and smaller reptiles with speed and precision. Marine environments were dynamic, shaped by currents, nutrients, and predator-prey interactions. Coral reefs offered shelter to fish, mollusks, and invertebrates like ammonites, which were abundant enough to become key fossil markers. Coastal and shallow waters supported interactions between terrestrial and marine ecosystems, creating a rich, interconnected web of life. From dense fern prairies and towering conifers to warm, shallow oceans filled with predators and prey, the Jurassic was a world in constant motion, shaped by climate, geology, and the interplay of life at every level. The stage was set, and every organism from the smallest fern spore to the largest ichthyosaur played a part in a complex, interwoven story of survival, adaptation, and evolution. The Jurassic seas were alive with diversity, hosting the ancestors of many modern fish groups, including teleosts, which today account for the majority of fish species. Among these ancient waters swam both tiny schooling fish, darting in vast synchronized groups, and larger, solitary hunters prowling reefs and open waters. Their scales and bones are commonly found in fossil deposits, often alongside ammonites and marine reptiles, revealing the deep interconnection of these ecosystems. Sharks had already existed for hundreds of millions of years, and in the Jurassic, they thrived. Some were small, preying on fish and invertebrates, while others were larger, capable of challenging reptiles within certain ecological niches. Though they never matched the colossal size of plesiosaurs, sharks' adaptability ensured their survival. Fossilized teeth showcase a remarkable variety of forms, from slender needles for grasping slippery prey to broad, serrated blades for cutting flesh. This diversity allowed sharks to exploit a wide array of opportunities in the ocean. Ammonites, relatives of modern squid and octopuses, were central to the Jurassic seas. Their coiled shells housed soft bodies, and they moved through water using jet propulsion, extending their tentacles to capture prey. Sizes varied greatly. Some ammonites measured only a few centimeters, while others exceeded a meter in diameter. Their intricately chambered shells regulated buoyancy and often displayed striking patterns. Ammonites evolved rapidly and were so widespread that paleontologists used them to date rock layers. They were a vital food source for fish, marine reptiles, and even early seabirds, making them a cornerstone of marine food webs. Coral reefs were another defining feature of the Jurassic oceans. Built by tiny coral polyps secreting calcium carbonate, these structures spread across warm, shallow seas, particularly in the Tethys Ocean. Reefs created habitats teeming with life. Small fish darted between coral branches for shelter. Crustaceans scuttled across the reef floor, mollusks clung to surfaces, and sponges filtered nutrients from the water. Predators, including reptiles, patrolled the reefs, making them zones of both opportunity and danger. The interaction between land and sea was constant. Rivers carried nutrients from forests and prairies to coastal waters, feeding plankton blooms that supported entire food chains from microscopic algae to apex marine predators. Occasionally, dinosaurs left footprints on tidal flats, preserved for millions of years, showing where terrestrial life touched the sea. Pterosaurs, the flying reptiles of the time, dove to catch fish or scavenged along coasts, blurring the line between terrestrial and marine ecosystems. Yet, the Jurassic oceans were not without hazards. Storms and hurricanes, intensified by greenhouse conditions, battered coastlines and reefs. Volcanic eruptions occasionally poured lava into shallow seas, decimating local life before creating new habitats as rocks cooled. Predators prowled constantly, making every swim a potential risk. Despite these dangers, life flourished. Populations rebounded, species adapted, and ecosystems remained vibrant. A dive into a Jurassic sea would have been a sensory marvel. Sunlight filtered through warm, clear water, glinting off ammonite shells and fish scales. Schools of fish swirled around, parting as an ichthyosaur surged past. In the distance, a plesiosaur glided gracefully, its long neck weaving to snatch prey. Below, a coral reef sprawled in intricate patterns, buzzing with activity. Occasionally, the shadow of a pliosaur would loom, massive jaws open, reminding all that survival was never guaranteed. Coral reefs were engines of life, built layer by layer over millions of years by corals, sponges, and algae. They provided shelter, food, and breeding grounds. Small fish, juvenile ammonites, and even some marine reptiles relied on reefs for protection. Predators including ichthyosaurs, plesiosaurs, and sharks constantly circled, making reefs centers of tension and activity. Beyond shelter, reefs influenced water chemistry, stabilized microhabitats, and shaped currents, acting as ocean engineers as much as homes. Fossil reefs today reveal not just corals, but entire communities of life. preserving snapshots of Jurassic ecosystems. On land, the story of the Jurassic was dominated by the sauropods, enormous, long-necked dinosaurs like Brachiosaurus, Diplodocus, and Apatosaurus defined the landscapes they inhabited, their sheer size reaching over 20 meters in length with necks as long as buses, and bodies weighing dozens of tons. Transformed ecosystems. They reshaped vegetation, created pathways through forests, and fertilized soil with their dung. Moving in herds, adults protected juveniles and systematically grazed vast areas. Sauropods' digestive systems were equally remarkable, with teeth suited for stripping leaves, long guts for fermentation, and possibly gastroliths to grind plant matter. They extracted energy efficiently to sustain their immense bodies. Their size offered protection from predators, helped regulate body temperature, and supported rapid growth from hatchlings no larger than a football to giants exceeding 20 meters. Vertebrae filled with their sacks reduced skeletal weight while supporting massive structures, enabling mobility and efficient respiration, traits shared with their bird descendants. While sauropods ruled through size, predators tested them. Allosaurs, the apex Jurassic hunters, dominated floodplains and prairies. Adults reached 9 to 12 meters, with strong legs, long tails, and serrated teeth designed for slicing flesh. Agile, balanced, and armed with clawed hands, they could hunt or scavenge effectively. Fossil evidence shows they attacked large prey, including juvenile and weakened sauropods, and possibly hunted in loose groups where prey was abundant. Smaller theropods targeted mammals, lizards, and young dinosaurs, creating layered predator niches. Predator-prey interactions shaped evolution. Herbivores like stegosaurs defended themselves with spikes and armor, while predators like allosaurs adapted speed, strength, and versatility. Fossilized bite marks and pathologies reveal survival struggles, competition, and occasional cooperative behaviors. These interactions maintained balance, driving adaptations on both sides. In the Jurassic, both oceans and land were theaters of life, from microscopic plankton to giant sauropods, from ammonites and coral reefs to allosaurus stalking floodplains. Every organism played a role in a complex web of survival, competition, and evolution, illustrating how dynamic, interconnected, and extraordinary this period truly was. Allosaurs themselves bear witness to the harsh realities of life as apex predators. Fossilized skeletons reveal healed broken bones, showing that these creatures survived serious injuries. Some carried infections that would have weakened them, yet they endured. To live as a predator required more than strength, it demanded resilience. Injuries could come from struggling prey, rival predators, or accidents during hunts. Still, allosaurs thrived across the Jurassic world, adapting to shifting continents and changing climates. One of their greatest strengths was adaptability. They were not restricted to a single prey or environment. They could hunt sauropods in dense forests, stegosaurs on open plains, or smaller herbivores along riverbanks. Their versatile bodies allowed them to adjust to varying conditions. As ecosystems transformed, allosaurs could follow prey into new territories instead of vanishing. Their relatives spread widely, leaving fossil traces in Europe, Africa, Asia, and North America. The presence of these predators shaped every aspect of herbivore behavior. Herding was not only a defense against environmental hazards, it was a survival strategy against predators. Moving in groups reduced the risk to individuals, while defensive adaptations like plates, spikes, and armor evolved under constant threat. Even the speed and agility of smaller herbivores were responses to predator pressure. Without allosaurs and their kin, the evolutionary arms race of the Jurassic would have been entirely different. Picture the Jurassic landscape. It was not a serene parade of giants grazing undisturbed. It was a delicate balance, where a predator's shadow could fall at any moment. An allosaur emerging from a forest edge could scatter a herd, a young sauropod straying from its group, risked being hunted. Even predators faced threats from rivals, challenging their kills. Life was in constant motion, shaped as much by hunters as by the hunted. Yet these predators were not mindless killers. They lived by instincts honed over millions of years, focusing on survival, growth, and reproduction. They were essential players in ecosystems, maintaining balance through checks and pressures in every direction. Without them, herbivore populations might have exploded, destabilizing the environment. With them, the system maintained a dynamic equilibrium. Allosaurs left a mark not only on the fossil record, but on our imagination. Standing before a museum skeleton, jaws agape and claws extended, it is easy to imagine the fear it inspired. But these predators were more than fearsome hunters. They were part of a complex web connecting ferns, cycads, sauropods, stegosaurs, and even the smallest mammals. Every step they took sent ripples through this web, influencing countless lives. Above the Jurassic forests, skies were dominated by pterosaurs, the first vertebrates to master powered flight. For tens of millions of years, they filled the air. With glides and dives, their long wings stretched between elongated fingers. Yet during this time, another story quietly began, one that would ultimately transform the skies forever. The dawn of birds. The earliest birds did not resemble modern sparrows, crows, or hawks. They were closer to their dinosaur ancestors, straddling the line between two worlds. Archaeopteryx, discovered in 19th century limestone quarries in Germany, remains the most famous of these early birds. Its fossils show a puzzling mix: feathers, wings, and a wishbone typical of birds, alongside teeth, claws, and a long bony tail unmistakably dinosaurian. Archaeopteryx was a mosaic, a creature in transition, demonstrating the gradual evolution of flight from small feathered theropods. Feathers existed long before true birds. Many small theropods bore simple filamentous feathers, likely for insulation or display. Over time, these structures grew more complex, capable of catching air. The leap from feathers for warmth or show to feathers enabling flight was gradual, and, in the Jurassic, it was already underway. Archaeopteryx and its relatives experimented with the skies. Flapping wings formed from arms rather than membranous skin, learning to glide and maneuver through dense forests. Flight for these early birds was clumsy by modern standards. Their wings could flap, but their skeletons lacked the refinements of contemporary birds. They likely relied on short bursts of flight or glides between branches to navigate forests and avoid predators. Yet feathers provided more than a pathway to flight. They insulated, aided in display, and offered camouflage. The discovery of Archaeopteryx was pivotal in paleontology, emerging as Darwin's theory of evolution was debated. Here was a fossil that bridged the gap between reptiles and birds, a tangible transition. Yet in its own time, Archaeopteryx was just one of several small feathered creatures taking advantage of Jurassic environments. The other feathered theropods likely existed in Asia and elsewhere, though preservation of fossils was rare. Jurassic forests of conifers and cycads provided perches, while ferns and understory plants offered cover. Insects, lizards, and small mammals were abundant prey. Early birds had to navigate a world already filled with aerial competitors, yet their feathers gave them a unique advantage: control over lift and maneuverability. This subtle edge would, over millions of years, allow birds to diversify and eventually surpass pterosaurs in dominance. Their diets were varied. Insects were likely primary food, but small vertebrates and scavenged remains supplemented their meals. Clawed wings may have allowed climbing, and long, stiff tails aided balance and maneuvering. In life, these birds resembled feathered dinosaurs, hopping and gliding rather than soaring. Yet this was enough. In dense forests with abundant cover and predators, short flights could mean the difference between life and death. Early birds influenced the behavior of other animals. Insects adapted to new aerial hunters. Mammals became more vigilant, and even pterosaurs may have sensed competition. Birds layered new interactions into complex food webs, small but significant players in their ecosystems. Their importance lies not in size, but in potential, the beginning of a lineage that would outlast the giants of the Jurassic. Meanwhile, the world was full of life at every scale. Mammals scurried in shadows, insects buzzed through forests, amphibians croaked near streams, and small reptiles hunted and hid. Though tiny, these creatures were crucial to ecosystem balance. Mammals, descendants of early synapsids, were small, agile, and nocturnal, avoiding predators while exploiting niches dinosaurs could not occupy. Their teeth and metabolisms allowed them to consume insects, small vertebrates, and plants efficiently, while fur provided insulation. Insects thrived in staggering numbers, shaping every ecosystem as decomposers, predators, and prey. Dragonflies hovered above wetlands, beetles scuttled across decaying logs, ant-like insects defended tunnels, and mosquito-like forms fed on reptiles and amphibians. Amphibians, lizards, turtles, and early crocodile relatives further diversified. These small-scale niches, together, these tiny travelers sustained the energy balance of ecosystems, recycling nutrients and feeding larger animals. The Jurassic was alive with sound as well as sight. Forests hummed with insects, croaking frogs, and squeaking mammals. Herbivores communicated with low-frequency rumbles, coordinating herds or warning of predators. Predators roared, hissed, or stomped through vegetation. Wetlands added layers of splashing water, calls of pterosaurs, and the constant hum of insects, even at night. The chorus continued, with nocturnal mammals, frogs, and small predatory reptiles filling the darkness. Sound was survival. Herbivores relied on alarm calls. Predators listened for rustling prey, and silence could signal imminent danger. Fossilized inner ears suggest dinosaurs were sensitive to low frequencies, and skull-resonating chambers indicate sophisticated sound production. From dawn to dusk, the Jurassic soundscape vibrated with life, from insect wings to dinosaur rumbles, predator calls, and the first tentative notes of early birds. In this world, giants and tiny creatures alike mattered. Allosaurs and sauropods dominated visually, but small mammals, insects, amphibians, and early birds maintained the vital threads that held ecosystems together. Survival depended not just on size or strength, but on adaptability, cunning, and the intricate balance of interactions across all levels of life. The Jurassic was a world in motion, alive in ways both grand and subtle, a world where every creature, no matter how small, played a role in the complex story of life. When the storm finally passed, the forest came alive again. Calls echoed across the canopy, louder now in the cooler, post-rain air. Evening brought its own symphony. Day-active creatures retreated into quiet, while night-active animals grew bold. This cycle repeated endlessly, changing with the seasons, yet always returning. Picture yourself standing in a Jurassic forest clearing. You hear the hiss of wind brushing through conifer needles, the high-pitched chirps of small reptiles, and the constant hum of insects brushing past your ears. In the distance, a sauropod rumbles, a sound so deep you feel it in your chest as much as you hear it. Nearby, a stegosaur bellows, warning of an unseen predator. Then, suddenly, all calls fall silent. The forest holds its breath. An allosaur emerges, its growl vibrating through the earth and your body. The pause in the natural chorus is profound, but after it moves on, the sounds gradually return. First insects, then birds, then the deeper voices of giants. This layering of noise and silence, this pulse, was the heartbeat of the Jurassic. The soundscape carried more than noise. It was information, warnings, mating calls, and hunting signals. Life in Jurassic forests, plains, wetlands, and shallow seas depended on listening closely. Every species, predator or prey, needed to decode these signals to survive. Beneath it all, the earth itself was restless. Volcanoes erupted, tectonic plates shifted, mountains rose, and rift valleys opened. Dinosaurs, plants, and marine life had to adapt to a planet in constant motion. Fire and stone shaped the world as much as rivers, forests, and oceans. Some eruptions were sudden and violent. Lava fountains spouted high, rivers of molten rock poured downhill, and ash clouds turned day into twilight. Forests were swallowed, rivers boiled, and animals scattered. Yet even in destruction, new land, fertile soils, and ecological opportunities emerged. Quiet volcanic activity also reshaped life, slowly spilling lava or depositing nutrient-rich ash that rejuvenated forests. Ferns and cycads were often the first to reclaim scorched ground, paving the way for towering conifers. Earthquakes, too, reshaped the landscape. Plates shifted, causing sudden jolts, cracking rivers, and triggering landslides. Herds of dinosaurs sensed the tremors and scattered instinctively. Entire coastlines could be altered overnight, forcing life to adapt instantly. Even the atmosphere responded. Volcanic gases and ash influenced climate, sometimes cooling the earth temporarily, sometimes driving warmth that nurtured growth. Marine life was not spared. Ash changed water chemistry, sometimes reducing oxygen or making waters more acidic. Lava entering shallow seas killed creatures instantly. Yet new coastlines and underwater platforms soon became thriving habitats. The Tethys Ocean, in particular, bore the marks of constant geological reshaping, its shores and reefs evolving alongside shifting continents. Imagine standing near an erupting rift valley. First, the ground trembles, shaking trees and sending animals fleeing. Then, a glowing crack opens as magma rises. Hours or days later, fountains of lava soar, rivers of molten rock flow, and ash clouds darken the skies. Lightning sparks through the clouds, and night horizons glow red with fire. Some creatures are caught, their remains preserved in ash, leaving behind fossils that tell stories of sudden catastrophe. But life endured. Streams ran across cooled lava, forests grew on volcanic slopes, and animals adapted to landscapes punctuated by dormant cones. Herds of sauropods moved across plains nourished by volcanic soils. Predators followed, rivers carved, valleys through hardened lava, and ecosystems thrived in spite of or perhaps because of the constant geological challenge. The Jurassic climate added another layer of complexity. With no polar ice caps, warmth extended from equator to poles, seas were higher, shallow, and abundant, stabilizing currents and distributing heat worldwide. Yet seasonal variation existed, defined not by snow, but by wet and dry cycles, monsoon-like. Rains transformed lush floodplains, followed by dry spells that forced migrations and survival strategies. Storms were frequent and ferocious, driven by warm seas. Torrential rains, high winds, and coastal flooding could reshape landscapes in days. Smaller creatures hid in burrows, larger ones relied on mobility and resilience. Lightning ignited fires that cleared old vegetation, creating fertile ground for new growth. Sedimentary layers, mud cracks, ripple marks, and growth rings in fossilized wood all tell the story of these repeating cycles. Volcanic eruptions layered complexity atop climate. Ash clouds cooled regions temporarily. Rain mixed with ash created acidic soils, yet life persisted, regrowing forests and wetlands. As ecosystems adjusted and evolved, reproduction thrived in constant warmth. Dinosaurs nested safely, eggs incubated naturally, insects flourished, and plants grew year-round, though productivity varied with rainfall. The Jurassic was a laboratory of evolution. Dinosaurs, mammals, amphibians, insects, and marine life were constantly tested. Sauropods stretched into the largest land animals known. Stegosaurs bore bony plates and spiked tails. Ornithopods grazed efficiently. Apex predators like allosaurs hunted, while smaller theropods experimented with traits that would eventually give rise to birds. Lighter skeletons, flexible wrists, and feathers for insulation, display, balance, and eventually, flight. Oceans mirrored this experimentation. Ichthyosaurs evolved for deep hunting. Plesiosaurs specialized in long or short-necked forms. Ammonites diversified endlessly. Reefs flourished with corals, sponges, and algae. Crustaceans adapted to crush or scrape. Sharks experimented with teeth. Fish with speed and maneuverability. Plants, too, innovated. Conifers grew tall. Cycads and ferns spread across floodplains. Horsetails thrived in wetlands. Seed dispersal strategies evolved, interacting with insects and wind. Fires, floods, and droughts filtered out the weak and allowed the adaptable to flourish. Even the small mammals carved niches, nocturnal, burrowing, gliding, climbing, each adaptation a small survival experiment. Amphibians, reptiles, and insects followed their own paths. Every environmental disturbance, volcano, storm, flood was a test, and evolution responded. Survival was not guaranteed. Predators hunted relentlessly. Herbivores grazed under constant threat. Every day, life was a balance of risk and opportunity, a dance of predator and prey. Massive sauropods needed hundreds of pounds of vegetation daily. Their bodies, necks, tails, and digestive systems all evolved to sustain that appetite. In every corner, life thrived in diversity, responding to geological, climatic, and ecological challenges. Each forest, valley, and coastline was unique, molded by evolution as an ongoing experiment. The Jurassic was a time of creative destruction, a workshop where life was continuously tested, refined, and reshaped. A world of giants, storms, fire, and endless adaptation. Imagine a world to 100 million years ago, a planet teeming with life, yet balanced precariously between survival and extinction. Giant creatures roamed lush landscapes, while tiny insects and mammals thrived in shadows. Every step, every movement, every decision mattered. In this world, survival was not a guarantee, it was a constant struggle, an ongoing dance between predator and prey, plant and herbivore, insect and mammal, ocean and land. Herbivores like the massive sauropods fed endlessly, moving across plains in search of enough foliage to sustain their enormous bodies. But their enormous appetites forced them to migrate constantly, shaping landscapes, stripping vegetation, and opening new paths. Their movements were visible on ancient soils, trackways, pressed into mud, fossilized footprints stretching for hundreds of meters, frozen in time. Adult sauropods were nearly untouchable by predators, but the young relied on the protection of the herd. Adults formed living shields, encircling the juveniles to fend off danger. The very survival of the next generation depended on this vigilance. Other herbivores had different strategies. Stegosaurs, armored giants with spiked tails, could not outgrow predators like the sauropods. Instead, They defended themselves with plates along their backs, possibly for signaling or thermoregulation, and a deadly tail called the thagomizer. Fossil evidence shows puncture wounds on predator bones, clear signs of failed attacks. These creatures taught the lesson that survival often meant standing your ground. Smaller herbivores, ornithopods, and other nimble species relied on speed, agility, and acute senses to avoid becoming a meal. Their sharp beaks allowed them to feed efficiently on plants ignored by larger species, reducing competition but never eliminating risk. A single misstep, a moment of hesitation, or separation from the group could mean instant death. In the Jurassic, life was measured in seconds and every decision carried weight. Predators, in turn, faced their own perilous challenges. Allosaurs and other apex hunters could not attack indiscriminately. A fully grown sauropod could crush them. A stegosaur could impale them. Even smaller herbivores, when moving in groups, could trample predators. Every hunt required patience, precision, strategy, and sometimes luck. Fossilized injuries on predator skeletons, broken ribs, bitten limbs. Infections show us that failed hunts often came at great cost. Some predators adapted by scavenging, taking advantage of carcasses left by disease, floods, or other hunters, though competition for these meals could be fierce. Even the tiniest creatures shaped survival. Insects, often overlooked, were indispensable. Swarms consumed carrion quickly, recycled nutrients, and helped spread spores and seeds. Small mammals relied on them for food, while larger animals endured their bites as constant irritants. Survival, it seems, depended on a careful balance at all scales, from the minuscule to the massive. The seas of the Jurassic mirrored this delicate equilibrium. Ichthyosaurs hunted fish and squid using speed and vision. Plesiosaurs, with their long necks, struck swiftly, while pliosaurs dominated as apex predators capable of taking nearly anything. Fish darted in schools, using numbers as protection. Ammonites relied on shells and agility. Sharks evolved specialized teeth, adapted to piercing, slicing, and crushing, testing multiple strategies for survival. Here, too, the advantage was fleeting. Constant vigilance and adaptation were essential. Weather, too, shaped survival. Storms could scatter herds, flood nesting grounds, or carry carcasses downstream. Predators might starve during droughts. Herbivores could lose their young to floods. Small mammals could survive only by retreating into burrows for days. Life was not simply predator versus prey, it was a relentless contest against the elements themselves. The fossil record preserves these stories. Trackways capture herds in motion, predator and prey side by side, frozen in mud millions of years ago. Bone beds reveal mass deaths, sometimes from floods or drought, while healed wounds show individuals who endured attacks. Fossils also shed light on social behaviors. Sauropods, stegosaurs, and other herbivores reduced predation risk through group living. Predators may have hunted in coordination, while communication through sight, sound, or movement helped species survive. Each behavior was refined over millions of years of trial, success, and failure. Now, imagine walking through that world. A small mammal scurries from its burrow, whiskers twitching as it hunts insects. A dragonfly hovers above a pond, vulnerable to a snap from a quick reptile. Herds of sauropods move steadily across plains, their young protected at the center. An allosaur watches from a ridge, calculating the risk of an attack. Plesiosaurs glide gracefully beneath ocean waves. Every scene is survival in motion, predator and prey in constant tension. This balance, remarkably stable for millions of years, ensured ecosystem continuity. Plants fed herbivores. Herbivores fed predators. Scavengers recycled remains, and decomposers completed the cycle. Disruption, storms, volcanoes, shifting continents tested the system. Yet life persisted, adapted, and thrived. Survival wasn't about dominance, it was about adjustment, awareness, and resilience. Fossils allow us to see these dynamics. Dinosaur skeletons reveal posture, movement, feeding habits, and social interactions. Trackways show herd movement, predator-prey encounters, and even daily routines. Nests and eggs inform us about reproduction, growth, and parental care. Plant fossils reveal forest structure and vegetation types, while insect fossils show intricate interactions with flora and fauna. Coprolites, fossilized droppings, connect diet with predator-prey relationships. Every fragment contributes to a larger story. The seas, too, provide vivid evidence. Ammonites reveal their abundance and rapid evolution. Ichthyosaurs show live birth, and plesiosaurs demonstrate aquatic adaptations. Even volcanic ash layers, which rapidly buried communities, preserved snapshots of entire ecosystems. Fossils reveal not just life, but death, injury, disease, endurance, and resilience. Every discovery is a testament to adaptation and survival in a complex, interwoven world. Walking through this Jurassic world, you see towering conifers, endless prairies of ferns, oceans teeming with life, skies alive with flying reptiles. Sauropods move like living mountains, stegosaurs swing spiked tails, and allosaurs weigh risks carefully. Insects hum, mammals scurry, amphibians croak, storms sweep across valleys, and continents shift imperceptibly. The Jurassic was never static, it was dynamic, relentless, and full of life. Yet, the legacy of this age remains embedded in our world. Birds descend from feathered dinosaurs, crocodiles retain ancient body plans, insects continue roles shaped millions of years ago, forests, continents, and rivers carry the imprint of the Jurassic. The patterns of survival, balance, and resilience established then echo today. Food chains, predator-prey dynamics, and ecosystem rhythms continue, shaped by the same fundamental principles. Imagine a single Jurassic day. Morning light filters through conifers, insects buzz, reptiles bask, herds of sauropods move slowly. Across plains, predators stir, storms roll in, drenching the land. Evening cools. Frogs and insects chorus, mammals emerge cautiously, early birds flutter between trees. This rhythm repeated for millions of years, an endless cycle of challenge and adaptation, captured forever in stone. Fossils are not just relics, they are voices from the past. Each tooth, track, leaf, or shell tells a story. Extinction and survival, injury and recovery, predator and prey, plant and herbivore, sea and land, they all speak across time. Life endured, adapted, and thrived, setting the stage for the world we inhabit today. The Jurassic may feel distant, but it lives on. Its creatures, plants, and landscapes shaped the very foundations of our planet. The balance they navigated between danger and sustenance, growth and decay, survival and extinction continues to govern life on Earth. And as you return to your present world, remember, the Jurassic is not gone. It is folded into the present, written into stone, carried forward in living descendants, and waiting for you to discover whenever you choose to look back.